Hey everyone, in this video we are going to act like real world data scientist, solving a loan default problem using a real lending club data. Imagine you work at a bank. Before giving money to someone, you want to predict if they'll pay it back. That's exactly what we are building, a machine learning model that helps decide who gets approved. We'll clean the data, explore patterns, visualize important trends, build a model, and explain how it could help save millions. Ready? Let's go. You can find the data in Kaggle and download it through the link that is provided in the description. And before diving into building models, cleaning data, and exploring data, we are here to discover some new words or the words that are in our financial industry, finance, technology, or industry. So, the loan default is when a borrower stops repaying a loan, and binary classification is an ML task that predicts whether the output is 0 or 1, that is default or no default. And the risk segmentation is grouping customers by likelihood of repayment, like how much are the customers risky for that particular bank. And what do you mean by underwriting? Approving or rejecting the loan applications. And loss mitigation is steps to reduce the financial losses on bad loans. So how do we overcome the bad loans, or the people we have given it to the incorrect person? So how do we overcome our loss? That is considered to be loss mitigation. And stakeholder insights is data backed recommendations for business teams. So that's the insights that we draw to our visualization and model building accuracy while exploring the data and how we present it to our stakeholders. Now, in the same way, we are going to build the production ready code, and I'm using a Visual Studio Code for this. I've created a folder loan data, and which has the data folder in which we store our data set that is used for our building a model. And I've also created notebooks folder to store our Jupyter notebooks. If we create anything, mostly we use Jupyter notebook for EDA and visualization purposes. And the source folder contains the data cleaning files and the model building, model evaluating, feature engineering, all the Python files. And at the end, we'll consider or combine all these files that are present in the source folder into a main.py file, which runs and is the main file that is used for our ML pipeline. Now let's get started with cleaning our data. I'm going to create a new file in our source folder named data underscore cleaning dot py. Here I'm going to create a function for cleaning and loading the data. Creating functions help us keep the code modularized and more understanding. And for I am loading the data and cleaning the data. So first, cleaning the loan status. So this part keeps only the rows we care about and removes the columns that are useless or empty, like throwing out junk mail before doing paperwork. So is in Now we are creating a column loan underscore default, which considers the fully paid off to be 0. I mean that's and the charge off to be 1. Okay, so df loan status dot apply lambda 1 if x equal to charged off, else 0. Now drop the columns that are not at all necessary for us, like ID, member ID, URL, description, title, zip code, and loan status, because we have created now df dot drop columns for call in drop underscore columns if call in df dot columns in place is equal to true. df is equal to df dot lock is null of dot mean, where we are deleting all the rows that has 30% of data, that has more than 30% of data to be null. So that's our df dot. Now we start by bringing all the tools and let's load the data and this clean load data function into a Jupyter notebook, and let's start our exploratory data analysis. Okay, now let's create a new file named eda.ipynb, which here creates our Visual Studio Code, Jupyter notebook, and let's import the required libraries. Pandas, import matplotlib dot py plot as plt, import cborn as sns. Now let me change my kernel to Jupyter notebook. Okay, and then read our data, pd.read underscore csv, and let's specify our dataset path, copy path, and read our dataset, and also print the top 5 rows of the dataset to see whether they have loaded the dataset or not. Shape of the dataset. Okay, the has read our file, and this is the top 5 rows in our dataset. Now let's find the shape of the dataset. So it consists of almost 2 million records, that is maybe 22 lakhs 60,688 records and 145 columns. And let's import the data cleaning module to this. So import from src import data underscore cleaning. Set the system path dot append os dot path for it to get the absolute path. Okay, and let's try running this. So we have given the absolute path, like going back to that and then finding out the src folder and the data underscore cleaning file and import clean underscore load from that file. Now let's clean the dataset, clean underscore load of the dataset by passing it through all the required steps before performing EDA. And now that let's look at the shape of that again, because we have trimmed. So from 145, where is the shape? Yeah, from 145, 2 million records to 145 columns, we have reduced the data to 1 million, 1.3 million and 85 columns. So that's what we have, the data that is necessary for model building, and it seems to be clean, and because we have removed almost the rows and the columns that are almost 30% empty or nulls. Next, let's start doing the exploratory data analysis. Let's first do it by distribution analysis. So default distribution. First generate count plot with loan underscore data, right? Loan underscore default, comma, data is equal to df, and then plt dot title of that visual is loan default distribution, and plt dot show, which displays our plot. So looking at this chart, this shows us how many people didn't pay back. So only 20% default, but the 20% causes a lot of loss. So these are the people with the loan default value as 1 didn't pay off. So even 20% of the people creates a great loss in a real time, considering a real time scenario. So next, let's visualize or explore the interest rates. So let's create a box plot for this. Is equal to loan underscore default, comma, y is equal to plt dot titling the visual for us to understand. Interest rate versus default, plt dot show off, which shows us the plot. So the borrowers who defaulted has higher interest rate. This means that they were already risky, but even see they have the higher default rates. Like you can see the mean, median and max, they are given a lot of interest rate, but even charging more didn't stop them from failing. So but they are still a loss to the company even after giving them a higher APR and all. They did not make any improvement in their paying back the loan. So next, the loan amount. Let's analyze or explore the loan amount. SNS dot you know what, I'll copy paste this one. And instead of interest rate, we are looking at how the normal people have given and how the people who charged off are giving the we have given the amount. So this seems that people who defaulted are borrowed slight morely. Maybe they are already stretched thin. It's like giving too many cookies to someone already full. So yeah, and also next, look at the loan purpose. Just putting the figure size. Is equal to 12,6. Then building the count plot for the purpose of their loan, and hue is loan underscore default. df, data is df, and purpose of loan versus default rate, plt dot show off. So this is big. Like, some loan reasons are like small business default maybe more, and some maybe we need to be careful while approving these types of loans, like the small business, debt consolidation, and the more charge-offs are in these kinds. So we need to concentrate on the purpose of the loan. For this, for house and car, there is very minute difference, but small business, home improvement, so this is where we find a lot of people, or the distribution of the charged off people. So we also need to focus on the loan purpose also. So that's for the EDA and the visualization and exploring this data. Now let's create a feature engineering, and in the source folder, feature underscore engineering.py file. What we do here is we create new features, or we fill in blanks and change text into numbers, like performing one hot encoding, so that the model understand it's like turning a form into a barcode that machine reads it better. So yeah, let's start. Import pandas as pd and define pre-processing the features, pre-process underscore feature, and pass the data frame to this. And for column in df dot, okay, there shouldn't be any space, and select underscore d types. There are the data types we are considering is, which include float 64 and int 64. For that, we are going to do def column and filling the null values, because if there are any null values, the model will generate an error while fitting the data into the model. So we are filling the null values with the median, and in place is equal to true. That's for filling the null values. And now let's for the first identify the categorical or the text values in the text data types in the data frame. Dot select underscore d types, which include object, and then df of column dot fill na with the mode. That's the most repeated value in the column. And then perform one hot encoding using getDummies function that's present in the pandas. And after completing that, we'll return the data frame. So this is about the feature engineering file. Next, go to the model building. Now create a new file named model.py, and let's import the library sklearn.ensemble import random forest. Oh my bad. Random forest classifier, and define the build underscore model function by passing and return the random forest classifier with random state is equal to 42. And it's just in this we are building a random forest model, like many little decision trees working together to predict who will default. So that's about model building. And next, let's evaluate the model. Evaluate.py and import sklearn metrics. Sklearn.metrics import classification report and confusion matrix. And create a function evaluate underscore model, pass the model x underscore test comma y underscore test, and the predictions is equal to model dot predict x underscore test, and then print the confusion matrix along with the classification report. Okay. We'll be talking more detailedly in our tutorials based on pandas and every functions and machine learnings explained clearly in a different playlist. Classification report. Yeah. So we'll use this evaluate.py to check how accurate the model is, and this tells us if we are making small loan approvals and catching the risky ones in time or not. So that's for the source folder, and now let's create the main.py file which connects all these required items. So first import all the required pandas, import as pd, and import sklearn.model selection from sklearn, import train, test and split next from src.data cleaning, import clean load data, clean load data, and next from src.feature engineering, import pre-process the feature from src dot model building import the model build model function, and next from evaluate import evaluate the model. Now let's try using try except exceptions and while loading the data. Df is equal to pd dot read underscore csv and copy the file path of the loan data. Copy path and then print data loaded. If not, if we get or it raises a file not found error, then raise a raise a file not found error like file missing or check your file path. Next, let's call our clean load function and pass the data frame. Let's see the indentation over here. So now we load our data, we also clean our data, we will be feature engineering our data. So we need to pass this df to preprocess feature function. And then we drop the target variable, splitting the data, we drop the target variable that when loading the data into x variable and then store the target variable into y. So we are dropping loan underscore default column while loading the data into x, and y is only consists of loan underscore default. And next we train and split the data. Train x test y train y test is equal to train test and split of x comma small y comma test size is equal to 0.3 and the random state is equal to, every time you run this it creates a random state. So that's how you split your data. And next is model building. Model is equal to build underscore model of, you're calling this function, and then you will fit the model with the training data. And then you will evaluate the model where you will be passing eval model x underscore test comma y underscore test. Yeah, so that's where you will be completing the model. And next let's try running this one. So while our model gets to run, let's talk about how to think strategically like a finance data scientist. So let's pause here and talk about something really important: how to think like a business analyst or a data analyst in the real world, especially in finance. You see, real world data science doesn't start with a Jupyter notebook. It starts with a question, a business problem, a risk, and a goal. So here's how you think through it step by step. So first you need to understand the business context. In our case, we are a lender, like a lending club. We give loans to people, but here's the problem. Some people don't pay it back, and that costs the company millions in losses. So the question we ask is, can we predict which loans are most likely to default before we approve them? That's a business problem. So now let's think like a stakeholder. Next, uh, thinking about the stakeholders, the underwriters, executive, and compliance officers, we do care about. What do they care about? So the underwriters want to avoid bad loans, and the executives want to grow their business without too much of risk, whereas the compliance wants the model to be fair and explainable, that tells you what kind of solution is useful. Now, what does a good solution look like? Like in this case, high precision, we don't give good loans to people who will default, and high recall, which we can catch most of the risky cases. So it runs fast and can be deployed in production. It's explainable and auditable. Now we are building not just a model but a solution. So don't just plot stuff randomly. Ask questions like, which loan purpose are riskier, or does the interest rate actually reflect risk? Are longer loan terms riskier than shorter ones? Do high income people default less? So these questions guide your EDA and feature engineering. Once you found a pattern like small business loans default more, ask, so what? What can the company do with this info? Like build a rule based flag, or adjust the pricing, or train their classifier, or tighten our verification steps whose loan purpose is small business or home improvement. Always tie your insight to an action. That's how your work becomes valuable. So, some of the real world scenarios in finance are repeated defaults in certain zip codes, like flag the region based risk. Loans with high amounts and low income, um, or poor repayment on 60-month loans. Rethink the duration and the offers that you are making to that particular group of people or the segment A. So higher defaults after employment gaps. So add employment stability feature. Like we need to focus on employment stability more. So this can we can draw insights by exploring the data or the type of customers that business holds. So in the finance world, data science isn't about math. It's about reducing the risk, improving ROI, and protecting the trust. So, how do you become a strong finance or a problem solver in finance? So, always start with who is the decision maker and what are they trying to reduce or increase or avoid. Work backwards from the KPIs and make your insights useful, like, building dashboards, monitoring them, and setting thresholds, report, and model building. Focus on interpretability, scalability, and actionable outcomes. Wrap. We didn't just build a model, we learned how to think like real world data scientists. How to understand the business problem, ask smart questions, explore data with a purpose, and like build a model that creates real impact and communicate it like a pro. If you found this helpful, hit like, subscribe, and drop your favorite finance use case in the comments. Keep solving real problems, keep learning, keep building, and I'll see you in the next one.